right. Welcome everyone. Thanks for checking out our online lecture here. Um, I'm already unhappy. Super basic stuff for inequalities. I hope everybody's used to this or is familiar with this, seen this before. I just said this the other day in class, I think, but I still think of greater than or less than symbols as the alligator eats the bigger number, right? 8 is larger than 4. So sometimes it's I forget. It's when I'm reading it. It's 4 is less than 8, obviously, but just if you just see the symbols, this way or that way, you may have to take a second to think like, okay, this is less than, this is greater than. Either way, not a huge deal. Just when you're filling out your equalities or your inequalities, excuse me, just make sure you have the open mouth facing the larger number. And then the second thing there is if we throw a line underneath the symbol, so this is less than or equal to. So like this would be a true statement. 5 is less than or equal to 5. And this would also be a true statement. 5 is greater than or equal to 5. So we'll get in when we get into our solving inequalities. We'll see some of the differences in how we approach these problems. I mean, there's really not a different approach per se. The answers are just slightly modified depending on whether it's a greater than or less than, or a greater than or equal to, or less than or equal to. But yeah, like I said, hopefully this stuff is all very very familiar to everyone. Here we have some properties for inequalities. So if A is less than B, and then you add C to both sides, A plus C will always be less than B plus C. Once again, if we take a look at that, so if we say 2, is less than 5 once again, and then let's say we add 3 to both sides, 2 plus 3 is less than 5 plus 3. So we know that would look like 5 is less than 8, and that is still true. So that checks out. So that's what property 1 is saying right there. Property 2, if A is less than B, and if C is greater than 0, then A times C will always be less than B times C. So what's that? What that's saying is you have an inequality, A is less than B, and C is a positive number. Right? So that's the key. That's what this is saying right here. C is greater than 0. So C is a positive number, not 0. If you multiply both sides of the equation by C, the A side, or in this case the left side of the equation, will always be greater than the right side. Because if you're multiplying by a positive number, you're going to make both sides equally larger, proportionally larger, I should say. So in our same example here, we have 2 is less than 5. 2 times 3 is less than, I almost said 2 times 3 again. 5 times 3. So 6 is less than 15. Checks out. Once again, these are not all encompassing solutions. These are, I'm just throwing some numbers out there to illustrate these properties. But feel free to mess around and try this out. But the key for this one is C is greater than 0. C is a positive number. Counter to that, if C is a negative number, we will then flip the sign around, the greater than or less than sign around. So if we have, once again, our same inequality here, let's say we have 2 is less than 5, but now we make C negative 3. So 2 times negative 3 is less than 5 times negative 3, and then what do we end up? We end up with negative 6 is less than negative 15. Uh-oh, that's not true. Negative 6 is greater than negative 15, right? So that's where that comes into play. Because it's essentially the absolute value of AC is going to be less, but since we're making both sides of the equation negative, it's going to result in the AC value being greater than now, because it's less negative, right? It has a smaller magnitude, and since they're both negative, the smaller magnitude negative number is actually greater than a larger negative number, a larger magnitude negative number. So that's what that's saying there. So that's just some of our basic principles for for inequalities. So let's take a look at how this affects us, or what kind of interesting stuff we can figure out and solve with this. So let's take a look at example 1 here, solving a linear inequality. So we have 4 minus 3y is less than or equal to 7 plus 2y. They're just jumping right into it with the less than or equal signs, huh? All right, so let's see. So we got 4 minus 3y is less than or equal to 7 plus 2y. Off the bat, we are going to approach this exactly like we did from the previous section. This is just like solving a linear equation, right? We don't really have to, the approach can pretty much be the same. We're going to try to group the variables on one side, and we're going to try to group the constants on the other side. That will not change. That is the same as linear equations. So I'm going to add 3y to both sides. And since we're putting the y, seemingly we're putting the y's on the right, I'm going to subtract 7 from both sides. Couldn't really avoid, I was trying to get all positive numbers, but couldn't really avoid it. So let's see what we end up with here. Over here, we'll end up with negative 3 is less than or equal to 5y. So that's what we got just from doing our inequality there, or excuse me, from doing our adding 3y and subtracting 7 from both sides. So now we do have all of our y terms, our variable terms on the right, and all of our constant terms on the left. So finally, our last step would just be to divide both sides by 5. And we end up with oh, my pen fell apart there, excuse me. We end up with negative 3/5 is less than or equal to y. Or if we want to rewrite this, y is greater than or equal to negative 3/5. So as you can see, so in that instance, we didn't have to do anything different from a linear equation. This could have been an equal sign. Our approach would not have changed at all. Let's take a look at this. Let's take a look at this from another perspective, or another approach. Let's say we have our 4 minus 3y is less than or equal to 7 plus 2y. Let's say we do it the other way around, right? We move the y's to the left and the constants to the right. So we're going to subtract 2y from both sides, and we're moving the constants over here, and we're going to subtract 4 from both sides, right? So we're going to do that. Oh, I thought that was going to snap to a straight line. It did not. So 4 minus 4 is 0. Negative 3y minus 2y is going to give us negative 5y. It's less than or equal to, and then over here we'll have 7 minus 4, so we'll have 3. Then positive 2y minus 2y is 0. So here is one of the rules that we do have to abide by when working with inequalities that we do not have to worry about with equations. When you divide or multiply both sides by a negative number, as you can see, this is kind of going back up here to property 3. If we multiply or divide, because multiplication and division are essentially the same, by both sides by a negative number, so like in this case, we're going to divide, that's a terrible looking 5. We're going to divide both sides by negative 5. When we do that, we have to flip our sign the other way around. Once again, just like what it says here, up here in property 3, right? A is less than B. If we multiply both sides by a negative number, AC becomes greater than BC. So that's what we're doing here. We're dividing both sides by negative 5. So when we do that, the left-hand side of the equation just becomes y, and the right-hand side of the equation is just negative 3/5, right? Nothing to it. However, before we had a less than or equal to sign, now we will need a greater than or equal to sign. And what you'll see is we end up with the same thing we ended up with before. So that is the one. I shouldn't say the one. There's a few other nuances, but that's the biggest thing that trips people up. If you multiply or divide both sides of the equation by a negative number, you have to remember to flip the inequality. So if it's less than, it becomes greater than. If it's greater than, it becomes less than. So that's really the biggest difference. I want to just touch on real quick different ways we can report our answers with inequalities. Usually with equations, it's just y equals x equals whatever. You just write x equals this, that's your answer. Maybe there's 2, x equals this, comma this, or x equals this and x equals this. With inequalities, there's three main ways to visualize your answers. One of them is this notation here. I can't remember the terminology the book uses. I usually just call this inequality notation. So we could say, we have inequality notation. And that is, I guess I can write out the word notation. It's really not that bad. So that's our y is greater than or equal to -3/5. That's a typical way to present your answer. Another typical way to present your answer is interval notation. I'm sure many of you guys have seen this, but I'm just gonna. There we go. Many of you have seen this. Maybe not called this. Let me write it out. So in this case, y is greater than or equal to -3/5. So the way you'd write interval notation would be bracket -3/5, comma, positive infinity, parentheses. So there's a few things going on here. Basically, what this represents, the numbers in here, represent the range of our answer. So our inequality notation is telling us that to make this equation true, right, to make this inequality true, the value of y has to be greater than or equal to -3/5. So if y is greater than or equal to -3/5, our original equation up here, 4 minus 3y is less than or equal to 7 plus 2y, will be true. So that's why, since y has to be greater than -3/5, our lower bound here on the left is -3/5, and this just goes to infinity. Because there's no upper bound on your answer, right? Positive 10 million would fit into this solution set, right? It would make this equation true if you plugged a 10 million in here. So there's no upper bound on our possible answer. So that's why the right number is infinity, because this represents the range of our solutions. Now, the brackets versus the parentheses. So what that means is a bracket means that -3/5, our lower bound number here, is included in the solution set, right? So that means -3/5 is a solution to this inequality. If we have a parenthesis, that means up to but not including. So the difference really, what that means is that's whether the inequality notation is less than or equal to. So if it's an or equal to inequality, your end condition will be bracketed, because that number is part of the solution set. If it's a parenthesis, that's when, if you just have, if our solution set was just y is less than 3. So in interval notation, that would be, I can't draw infinity signs, -infinity to 3, and this would be a parenthesis here because 3 does not make this inequality true. Right, 3 is not less than 3. So this would be the solution set here. Since in our case, our equation we did, y is greater than or equal to -3/5. -3/5 is in the solution set, so it gets a bracket. Infinities always get parentheses. You can never have the value infinity. It's always going to be a parenthesis, so that's that. And then the third way is graphical. Graphical notation. So what that means is you draw a number line. Oh man, come on, this usually like snaps if I draw. It's really not doing it. All right. So you draw a number line. It doesn't, and you don't have to start at 0. You can literally just put in the numbers that matter. So in this case, like, I'm just gonna have a -3/5 is really that's the only real anchor we have on this number line. So I'm gonna have a -3/5 here. And then you're just going to shade come on. Is this working? Oh, nope, still, why isn't it changing to green? This thing really doesn't like me tonight. All right, I guess we're just getting red. Since you can just, you can shade it like that. Some people just like to put like little bumps going this way. But this graphical notation, the big thing is if you want to have a solid circle, if the number you're highlighting is included in the set, and then like one we have over here where it's -infinity to 3, we might have a number line that looks like this, and then here's our 3. Since 3 is not included in that solution set, it would be an open circle. and then something like this. So those are the three main ways. Some problems, I'm sure, with my labs, I know sometimes they'll ask you for a specific notation on your solution, whether it be inequality. Like I said, I don't remember what they call this one, if it's inequality notation or if they have a specific name for it. I usually just call it inequality notation. But inequality notation, interval notation, or graphical notation. But they all mean the exact same thing. These three things here and these three over here, they all represent the exact same thing. The only difference is just how the information is being presented. That's really it. So okay, so let's. Where's my next problem here? One. There we go. Drag this back up here. Well, this is taking a while. Okay, so let's take a look at. So in this case, yeah. So here's graphing a solution. So we're still gonna have to solve it. I know they're changing colors. We're still gonna have to solve it. Like we did the previous problem. Oh, there's two inequalities here. Whoa, look at this. So negative 2 is less than 5 plus 3m is less than 20. So you rarely, if ever, run into equations with two equal signs. You can. It's kind of weird, but you can. But with inequalities, you'll see this not infrequently. Approach it just like an equation, and you still have to remember, if you multiply or divide by a negative, you have to flip the signs. The only thing here is, instead of just having two sides of the equation, we actually technically have three sides of this inequality, right? We have the left, the middle, and the right. So whatever we do to one of the expressions, we have to do it to all three. So, but approach is still the same. So like the first step here, we're going to subtract 5 from all three sides here. So negative 2 minus 5 is giving us negative 7 is less than 3m is less than 20 minus 5 is going to be 15. And then finally we will divide by 3, divide each term by 3, and we'll get negative 7. Keep in mind, we did not divide by a negative number, so we don't have to flip any signs, right? We're all good there. Negative 7/3 is less than or equal to m is less than or equal to, well, 15/3 is nice. That's just 5, right? Alrighty. So it's asking us to graph this solution. So let's throw this up on a number line here, right? So we got our number line. Oh, let's try that again. We got our number line. That was probably even worse. Once again, with these, like, you don't have to worry about putting every number on. Like, we don't have to go from negative 7/3 and go, negative 2, negative 1, 0, 1, 2, 3, 4, 5. You can literally just put the values that matter. So like in this case, we're just going to have negative 7/3, and then over here I'm going to throw a 5 in. That's it. So what this inequality notation is saying is negative 7/3 is less than m. So m is greater than negative 7/3, but also m is less than 5. So we're going to be highlighting the area between negative 7/3 and 5, and then we just have to do open circles, because 5 and negative 7/3 are not included in the solution. They're just the bounds, the upper and lower bounds on the solution. So they're open circles, and the middle section is highlighted there. Right? Cool. Good work, guys. Oh, I really sent these. Oh, way too low here. But yeah, like I said, for the most part, these inequality problems the approaches are pretty much the same as for an equation, just a regular equation. It's just that one wrinkle with the with the multiplying and divided by a negative. That's what I was trying to say there. So, all right, look, we're stepping up our game a little bit here. So we have a quadratic inequality here. So let's see what we've got. We've got x squared minus x is less than or equal to 12. Cool. It's okay. So we're going to approach this once again. I feel like I've said this enough times. We're going to approach this like it's an equation. And we're going to take a look at solving this how we would if this was an equal sign. right? This is a quadratic, so we're going to set it equal to 0 and then factor and go from there. So let's see what we get. So we get x squared minus x minus 12 is going to be less than or equal to, sorry, not equal to, less than 0, right? All right. So we've got that, and then now we can factor this. So let's see what we got here. So we got 2 is less than 0. A is 1, so that's pretty cool. So excuse me. So we have x's and x's. We've got negative. That's negative. So we're gonna have 1 negative and 1 positive. And then we're looking for 2 numbers that multiply together to give you 12 and have a difference of -1 or just a difference of 1. So I'm going to say -4 and +3. I feel pretty confident in that. So what we have here, so now we have a little bit of a difference. So if this were a equation, right? If this was equals 0, we would just say, oh, okay, x is equal to 4 or x is equal to -3, and we're good to go. When we have the inequality here, basically what we're saying is, since we know that one of these, but not both of these, have to be negative, right? Think about that for a second. So we have two things being multiplied together. We have x minus 4 times x plus 3. And then to be less than 0, what that means is you basically have to get a negative number from multiplying these two things together. And the way you get a negative number is multiplying a negative by a positive. So the way we check this is we know that 4 and -3 are kind of going to be like our critical points. That's a mathematical term from another topic, but it's very, very similar to what we're doing here. So what we can say is, if we draw our number line, right, we're going to draw our number line here, and what do we have? What did I say we have? We have -3 and 4. Yeah, those are kind of our situations. So what we want to do is we want to check values. Excuse me. We want to check values in each of these 3 intervals, right? So this interval is like -infinity to -3, and then we have this interval from -3 to 4, and then we have this interval from 4 to infinity. We kind of have these three intervals here. So if we were to plug a value in, let's say we just try -5, because -5 is in this interval, right? And I'm not even super concerned with what the values are when we plug -5 into this equation. All I'm concerned with is whether it's positive or negative. So if we plug -5 in here, -5 minus 4, sorry about that, -5 minus 4 is going to give us a negative value, right? Negative value. And then -5 plus 3 is also going to give us a negative value, right? -5 plus 3 is -2. So that's negative. A negative times a negative is a positive. So if we plug a value less than -3 into this equation, and well, this equation down here, we're going to get a positive value out of it. So that's not going to be a solution set to this equation. If we try the interval between 3 and 4, my pen tip keeps falling out. If we try a number between 3 and 4, just 0, because it's easy. If we plug 0 into the equation, 0 minus 4 is going to give us, I wrote -4. I don't even need, like I said, I don't even need the -4. I just need the 0. And then 0 plus 3 would be positive. So a negative times a positive will give us a negative. Look at that. And then finally, if we plug a number larger than 4 in to check this third interval here, we would get a positive and a positive, which once again gives us a positive value. So what that tells us is our interval that we're looking for is from -3 to 4. And then now the last part of the question would be, if we're doing this graphically or interval notation, is whether these are greater than or less than symbols. Or not greater, whether these are brackets or parentheses around our solution. A quick inspection should yield the result kind of obvious. They're going to be parentheses. If we were live right now, I'd ask you why, and I'd sit around and make you guess or figure it out. But the reason is, if you plug -3 or 4 into this equation, you get 0, right? The value you get the value of 0. So 0 is not less than 0. So clearly your answer could not be -3 or 4. So both would have parentheses. So if we were solving this graphically, these would be open circles, and this would go like that. Another way to, if a more algebraic way to solve this is if we did break this up into x minus 4 is less than 0 and x plus 3 is less than 0. You see, you would obviously get x is less than 4 and x is less than negative 3. Yeah. X is, sorry, it's just blank in there. X is less than 3, x is less than negative 4, x is less than 4. Jeez, it's getting late. So that would be the other way you could look at it, and then you could look at where those solutions overlap, and then that would kind of give you the same thing. I think I like the number line approach way better, but if you're really, you love your algebra, you can do it this way and then kind of interpolate your answer saying, so I know x has to be less than 4, I know x has to be greater than negative 3, and then kind of just you'd have to check to make sure it would only be where both of these. Some people will draw two number lines and then kind of you combine them and then you say it's only true where both of these are true. So obviously they would only be true between the two. So all right, so that's an example of a quadratic inequality. Man, I really scrolled these down really far, huh? A polynomial inequality. It's going to be pretty... Oh, I lost it. Come on. Oh, man, I got to do this the slow way. It's going to be pretty similar to our quadratic or even just solving polynomial equations. We're just going to run into kind of the same kind of deal here. There we go. Okay. So solving a polynomial inequality. So let's see what we got. So this is going to just, this is just going to turn into a quadratic if we take a look at this. So we have x cubed plus 2x squared minus 3x is greater than or equal to 0. First things first, you're always going to try to solve by factoring out the greatest common factor. In this case, we have an x in all of these terms. So if we factor this, we'd get x times the quantity x squared plus 2x minus 3 is greater than or equal to 0. And now we can factor this. We can factor this quadratic here. Let's see what we get. So we are looking for... Got to replace the tip on my stylus. So we have an x, and then now we're going to have two binomials here, greater than or equal to 0. So a value is 1. That's pretty cool. C is negative, so we're going to have a negative and a positive. And let's see, we're looking for two numbers that multiply together to give us 3 and add together to give us 2. So it's going to be 3 and 1. So the b value is positive, so we're going to have a 3 here and a 1 here. So in this case, our kind of our solutions we need to check, or our critical points, as I said in the last one. Once again, it's kind of appropriate, but not technically the name for this. Our values are going to be x equals 0, positive 1, and negative 3. So if we set up our number line over here, this time, I think this is the most numbers we've ever had, but now we have a negative 3, a 0, and a 1. Once again, this is not to scale at all. I mean, clearly negative 3 looks like it's the same distance away as 1. If you're really, OCD or a real stickler for that, you can always do that. But realistically, this graphical approach is strictly to visualize the solution. It's not really, it's not a to scale drawing of in any way. It doesn't need to be. So we can just draw it like this. But then if we go ahead and we start checking values, so if we plug in negative 4 into this, we'd get a negative, and then negative 4 minus 1 is going to give us another negative, and then negative 4 plus 3 is still going to give us a negative. So a negative times a negative is a positive times a negative is a negative. So this part's going to be negative. If we go in here between negative 3 and negative 1, negative 3 and 0, I'm going to try a negative 1. Negative 1 is negative. X minus 1, excuse me, negative 1 minus 1 is going to give us a negative value there, and then negative 1 plus 3 is going to give us a positive value, so that will yield a positive value along that interval. If I try 1/2 in here between 0 and 1, 1/2 is going to give us a positive, and then 1/2 minus 1 would give us a negative, and then 1/2 plus 3 would give us a positive, so that's going to give us excuse me, a positive times a negative is going to give us a negative, times a positive is going to give us a negative. And then, finally, we'll just pop a 2 in there, positive, 2 minus 1, positive, 2 plus 3, positive. So this would be positive. So once again, our solution set here. So we're looking for, in this case, we're actually looking for the positive sections because we're looking for when the equation is greater than or equal to 0. And in this case now, since it's equal to 0, these are going to be closed-in circles, right? So it's positive here to here, and it's also positive from here to infinity. So if we're looking for interval notation for this solution, we would have something like bracket -3, comma 0, bracket. I usually just put a comma. Sometimes you'll see a U, like for union notation. It's the same thing. I'll usually just put a comma, but either way is fine. I'm not sure which way my labs makes you do it. But then finally 1 and then comma, positive infinity, and this will, like I said, infinity will always be a parenthesis. But that would be the interval notation solution for this. So -3 to 0 and +1 to positive infinity. Guys, some great things. As I've said this numerous times in previous classes, these problems are super easy to check. They're super easy to do checks on. They're not necessarily super easy to guarantee you got it correct, but you can always go back and plug values into this and see if it makes it true, right? Like we would expect certain values to make this true, and we would expect certain values to make it false. The thing about inequalities is, you can't obviously check every solution, but you can check along the interval to kind of get an idea if you're correct or not. But either way, it can be helpful. Excuse me. Yeah, and then I guess like I said too. If you wanted to look at the algebraic solution for this, so you'd have x is greater than or equal to 0, and then x minus 1, so x is greater than or equal to 1, and then finally x is greater than or equal to -3 would be your 3 algebraic solutions. So if we kind of look at those on the number line, so you have 0, and it'll be all out here. And then over here, if we do want to kind of keep it the same, so this is +1, and then it goes that way, and then -3, -3, and then that would be that. So those would kind of be your 3 solution sets. Then you'd have to do, excuse me, you'd have to find out where these work and where these don't work. So it's like I said, I don't really put too much stock in this approach. I usually like to just set up my number line and check my positives and negatives. But you can take this approach and kind of try to figure out where this is going, because obviously if you're right, so if you're looking for spaces where you're positive, right? So if you have basically where there's no highlighting, your solution to this is negative. Where it's highlighted, it's positive, right? So we kind of draw. Actually, this would be a great time to use a different color here. Let me see. Yeah. So, right, you kind of have these intervals here. So down here you have, once again, this is negative, negative, negative. Negative times a negative gives you a positive, times a negative gives you a negative. So this interval would be negative. Over here, negative, negative, positive. So you have a negative times a negative gives you a positive, times a positive gives you a positive. positive, negative, positive, right? Positive times a positive is positive, or positive times a negative is a negative, times a positive, still a negative, and then positive, positive, positive is all positive. So that's another approach you can take. I think it's easier to do it this way, but if you like kind of like the overlapping visual of this, you can kind of do the same thing. It's really how you want to approach it. And then I guess for this one they didn't specify how they wanted their answer presented, whether they wanted it inequality notation, graphical, or interval. Usually once you get into multiple interval solutions, like in this case, I guess I just literally use the words, that maybe that's why, but usually you'll see interval notation as the most common. Man, I really put these way too far down. Usually you'll see interval notation as the most common, the common form. It's the most concise. I think it's the easiest to see. So that's usually why we'll have that. But all right, let's got a few more problems here. We'll take a look at, and then we'll call it a night here. Okay, so here is a rational inequality. Ooh, might look a little scary. It's not at all. Over x is less than or equal to 1. All right. So if we just do one small manipulation here and just multiply both sides by x, we end up with 2x minus 3 is greater than or equal to x. And now we just have a linear inequality, just like going back to example 1, right? So we move stuff around, we move all the variables to one side, constants to the other. So 2x, I'm just going to subtract 2x because then you're kind of already there. So we're left with negative 3 is greater than or equal to x minus 2x is going to be negative x. And then we'll divide both sides by negative 1. And then, so here's the kicker. We did divide by a negative. So we will have 3, positive 3 is less than or equal to x. Then if you really like to write variable first, x is greater than or equal to 3. So that would be another approach there. So if I guess, just to be thorough, it doesn't really ask, but x is greater than or equal to 3. So interval notation, we would have a bracket 3 comma positive infinity like that. Graphical notation, we have our number line, positive 3, solid circle, highlighted to the right to positive infinity. So those would be our three ways to show that. So yeah, that's pretty much that. Now I got to do this whole scrolling forever thing again. There we go. All right, so solving a rational inequality. Is that what I just said, or is that a different one? I think the kicker here is this one's equal to 0. So that's it's not equal to 0. It's less than or greater than, or equal to 0. I gotta lay these out a little bit better so I don't have to do this scroll thing. There we go. All right. So yeah, in this case, so the trick here is you got to be careful. You can't just we can't just multiply both sides by x, because then you lose x times 0 is going to give you 0. So with one like this, honestly, I'll just look. It's already factored for us. I take a look at like I said, my so-called critical points, and just take a look at where this, because we're just looking for wherever this is negative, right? So if we think about it, we know it's possible points that it could change would be at positive 1, negative 1, and 0, because this function doesn't exist at 0 because you have a 0 in the denominator, right? That would be a math rule. Zeros in denominators break functions. But if we set up our number line, that's probably way bigger than it needs to be. But negative 1, 0, and positive 1. like I said, utilize my colors here. So if I pick negative 2, right, I get over here negative 2 minus 1 is going to be a negative. Negative 2 plus 1 is also going to be a negative, and then divided by negative 2 is divided by a negative. So a negative times a negative gives you a positive divided by a negative gives you a negative. So that area is going to be negative. Plug in something like negative 1/2. Negative 1/2 minus 1 is going to give you a negative. Negative 1/2 plus 1 is going to give you a positive, and then negative 1/2 in the denominator is just going to be negative. So this is going to give you a negative times a positive. It's going to give you a negative. A negative divided by a negative is going to give you a positive. And we'll repeat this procedure for the positive values over here. So over here we'd have what? We'd have negative, positive, positive. Negative times a positive is a positive. Nope. Negative times a positive is a negative. Divided by a positive is going to be a negative. Then finally over here, so we'll have what? Positive, positive, and positive. So that would all give you positive values. So since we're looking for, really not really a need to do that in a different color. We're looking for the rate of this is less than or equal to 0. Right, so we're looking for these less than ones. So, excuse me. We know, so this, so we're looking for ones where it would be less than or equal to, so we're good to go there. So negative 1 would be included in our solution set, and it would go to negative infinity. This is all positive. So this next interval is negative. Positive 1 would be included in the solution set. However, 0 cannot be because of our equation, right? But from 0 to 1 would also work. But because if we take a look at 0, right, if we plug 0 into this function, yeah, the top will be negative, but the bottom won't exist, right? The denominator will cause the left side of this equation to not exist, so you wouldn't be able to have 0 as part of your solution set. It's always really important to check those. Like I said, I keep using the term critical points. It's from kind of a different concept in math, but it's very similar to what we're doing here. You always want to check those points. But if we're going to write this in interval notation, we'd have negative infinity to negative 1 with a bracket, comma, and then we're going to have a parenthesis, comma, positive 1, bracket, because negative 1 and positive 1 would both be in the solution, but like I said, negative infinity never is, and 0 is not. So, all right, cool. Hopefully these aren't too bad. Let's get cracking. Let's do one more. We got one more here. Oh, look at this one. This one looks big and scary, doesn't it, guys? Now we just have to scroll up for 10 minutes. Maybe I'll edit these breaks out of the video. I probably won't. It's more work than I need to do. I could just upload it, but it's really kind of annoying. I'll do better, guys. I'll do better. I'll start just putting them off to the side so I can just drag them. I tried to just space them, but I put, I guess, way too much space. And if any of you guys are good at OneNote, I know there is a tool to remove space in between the two, but for some reason my OneNote was being really wonky and I could not get it to remove the space. It just kept adding. I know how to use it. It's not, well, it probably is some kind of user error, but I swear I normally know what I'm doing. Okay, so couple different ways to approach this one, but realistically, I'm just going to treat it very similar to it's kind of a combination. We're going to take a linear approach, but then we're also going to see that it's a quadratic. So if we have our x squared minus 3x, right, all over x squared minus 9 is less than 4, I'm just going to multiply both sides by x squared minus 9. And then I end up with x squared minus 3x is less than 4 times the quantity x squared minus 9. And now I can distribute that 4. So I get x squared minus 3x is less than 4x squared minus 36. And now you can see we have a quadratic. So we just have a quadratic. So when we have a quadratic, we move all of our values to one side and set the equation equal to 0, or in this case, set the inequality to 0. So I'm going to just subtract 4x squared from both sides, and I'm going to add 36 to both sides. Over here, there's not really another 36. But then what we would get, negative 3x squared minus 3x plus 36 is less than or equal to 0. Cool. Oh man, we got that big annoying a value, but luckily we have an equation that can be completely factored. We can pull a factor out. In this case, you might think like, oh, I'll just grab a 3. I'm going to grab a negative 3 just to make this a value 1 and not negative 1. So if we factor a negative 3 out of this, we get x squared plus x minus 12, right, is less than 0. So now we have a nice factorable equation here. So what? Let's see. Let's set this up. So our a value is 1, so we have x and x. Our c value is negative, so we have a positive and a negative. And then we're looking for two numbers that multiply together. I think we literally had this same quadratic earlier. Two numbers that multiply together to give you 12 and have a difference of positive 1. It's going to be 4 and 3. So yeah, so if we set up, we know our critical points are going to be, once again, that is not a straight line. I know critical points is technically not the correct term, but I just keep saying it. You can't stop me. No, I should stop saying it. The values we need to check are going to be negative 4 and 3. So if we check what? Negative 5. Keep in mind we have a negative 3 out in front here, so that first term is always going to be negative. But then our middle term here, negative 3, or excuse me, negative 5 minus 3 would give us negative. And then negative 5 minus 5, excuse me, negative 5 plus 4 would still give us a negative. So negative times a negative is a positive, times a negative is a negative. If we plug a 0 in here, we get a negative, and then we get a negative, and then we get a positive. So a negative times a negative is a positive, times a positive is a positive. And then over here, just picked 5 for symmetry. Negative 3 is always negative. 5 minus 3 is positive, and 5 plus 4 is also positive. So negative times a negative times a positive is a negative, times a positive is still a negative. And in this case, we're looking for values that are less than 0. So our solution set is going to be that and that. Or in interval notation, negative infinity to negative 4, and all parentheses 3 to positive infinity. So that would be that. Oh man, I was just about to say something. I'm totally blanking now. But that's a quick rundown on inequalities. They're very similar to equations. The answers can be a little bit more complex. Not complex isn't the right word. A little bit more work because you don't just have a singular value as your answer. Your answer can be a range, or it can be multiple ranges. But a little bit of practice. And one thing I say this for pretty much every topic we talk about, but I think it's especially helpful with inequalities, is just do a quick common sense check at the end of your problem to see if it makes sense. Like same thing, like for this solution, for this last inequality here, or this last rational, 3 definitely should not be in your solution set, because if you plug 3 into that equation breaks the inequality. You'd have a 0 in the denominator, right? 3 squared is 9. 9 minus 9 is 0. So you'd have a 0 in the denominator. That blows up equations, right? Equations can't handle that. So like doing a double check of your solution sets to make sure, mostly to make sure your bounds are kind of the correct values, and that you have whether the parenthesis or the bracket to show whether they're included or not included is a good kind of, like I said, a common sense, or just a check at the end of the problem to see that you're on the right track. So cool. Thank you very much, and yeah, head on over to the next video.